Hi all, welcome to Go Classes. In this lecture we will study what is Cayley table. First of all, let me tell you, Cayley table or operation table or multiplication table, all these things are same. So we have already seen this operation table and the same concept we are going to revisit. So let me tell you, these three words are same. Cayley table, operation table, multiplication table, all these things are same. Okay, so what is this? So you can see, for any binary operation on a finite set, you can basically represent this binary operation which is on a finite set. You can represent this using the Cayley table, using the operation table. So remember one thing, for any binary operation on a finite set, you can create Cayley table. So even if you don't have group, if you have group, then also you can create Cayley table. If you have monoid, for that also you can create Cayley table. For semi-group also you can create Cayley table, and for groupoid also you can create Cayley table. So this Cayley table we can create for any binary operation on a finite set. Okay, your base set must be finite. For any binary operation on a finite set, we can create Cayley table. For example, consider this structure. Now look at this structure. First of all, you tell me, is this structure a group? In this structure we have conjunction. So this is clearly closed. So the closure property is definitely satisfied. So I can say that this structure is definitely a groupoid because the closure property is satisfied. Okay. And what about the associative property? Conjunction is associative. So I can say this structure, this complete structure, I can say that this is semi-group also. This is groupoid also, this is semi-group also. This structure will satisfy associative property because conjunction is associative. And you can see there is identity element also. So I can say this structure is monoid also. This structure is a monoid also because there is identity element. What is the identity element? Identity element is true. For the conjunction, identity element, that is true. And what about inverse property? There is no inverse property here. So that is the reason this is not a group. Why this is not a group? Because there is no inverse property. We do not have any inverse property. Why there is no inverse property? Let me tell you. Because tell me, what is the inverse of false? Remember, the identity element is true. So I am asking, what is the inverse of false? What should I write here such that I get identity element? I am asking, what is the inverse of false? For this false, what is the inverse? Means false. And what should I put here? What should I put here such that I will get the identity element that is true? So you can see nothing will work. If I put false, then also it will be false. If I put true, then also it will be false. So the point is simple, that this inverse does not exist. Remember, there is inverse for true, means I can say this true inverse will be true. Okay, for identity element, inverse will always be identity element. This true is the identity element. Identity element inverse is always identity element. So true inverse is true, but false inverse does not exist. I can say false inverse, that does not exist. So because false inverse does not exist, so I can say we do not have inverse property, and that is the reason this structure is not a group. So ultimately I can say this structure is basically groupoid and semi-group and monoid. Or I can simply say that this structure is basically monoid, because every monoid is semi-group, every semi-group is groupoid. So once I say that this structure is monoid, automatically I am saying that this structure is groupoid also, this structure is semi-group also. So for this structure I can say the answer will be monoid. Now you can represent this structure. Remember, this structure you can represent using a matrix type representation, and that is called Cayley table. This is called Cayley table. So Cayley table is just a matrix representation. This Cayley table, this is simply a matrix representation, nothing else. So you can see this is just an array, or I can say matrix representation, this type of representation. So this Cayley table representation we can create here. What will be that? For Cayley table representation, you write all these elements of the base set, you write them like this in order. For example, if you are writing in this order true false, then you write in this order true false. Okay, very simple. So you write in this order. Or for example, you can also write like this. If you don't want to write like this, then you can also write like this, false true. If you are writing false true, then you also write false true. Okay, so simple. So you write like this. Once you write like this, now you can fill this Cayley table. So this Cayley table is simple. This entry means false and false. False and false, that is false. This entry means false and true. False and true will be false. This entry means true and false, that will be false. So this entry will be false. and this entry means true and true, that will be true. So this is your Cayley table for this structure. Okay. So remember, if you have a finite set, let's assume you have a finite set S, and in this finite set, let's assume these are the elements. For example, A, B, C. Let's assume these are the element. You have a finite set, and let's assume there is a binary operation defined on this finite set. This binary operation can be anything. Let me call it hash. So this is your binary operation. Now in this situation, this binary operation you can represent. This binary operation we can represent using a Cayley table. This binary operation we can represent using a Cayley table. What you can do, the elements of the base set you can write. Okay, this is the header. I can say this is the header. This is called header. So this is called header, and you can see elements. I can write like this is also called the header. This is vertical header. This is horizontal header. Anyway, so the point is that you can write the elements of the base set. You can write like this ABC, ABC. Now in this situation, first of all, for example, what is this entry? Like you have this entry. This entry means A star A. A has A. Remember this entry. What this entry means? This entry means A has A. This is the entry. Similarly, if I ask you what is this entry? For example, if I ask you what is this entry means, remember, B has C. This entry means B has C. First of all, let me tell you that don't say that this entry is C has B. Don't do like this. Okay, always go from left to right, or I can say from row to column. For example, row B, column C, row B, column C, row B, column C. So this entry will be B has C. Similarly, you can notice, for example, if I ask you what is this entry, then this entry is going to be, what is this entry? This entry will be row C, column B, row C, column B. So I can say it will be like C has B, because I can say row C and column B. So this is the reason. So very simple. This is how you can create the Cayley table. Okay. So in this Cayley table, this entry, what this entry will be? This entry will be row A, column C. So it will be like A has C. So this entry is going to be A has C. This entry, what this entry will be? This entry will be A has B. So this entry is going to be A has B. Similarly, what this entry will be? This entry will be B has A, because row B, column A. So this entry is going to be B has A. And this entry will be B has B. This entry will be column row C, column A. So this entry will be C has A. And you can see finally this entry will be C has C. So this entry will be C has C. So this is the point. So this is how you can create Cayley table for a finite set. Your set must be finite, because if you have infinite set, then your Cayley table will just be infinite. It will just keep going on. So for this Cayley table, this table representation, this is also called Cayley table. This is also called operation table. This is also called multiplication table. Okay, even though you can notice this operation need not be multiplication. This operation can be addition. This operation can be subtraction. This operation can be any operation. Max, min, power. This operation can be any operation. Still, this table is called multiplication table. You can also call it operation table. You can also call it Cayley table. So the point is, this Cayley table you can create for any binary operation on a finite set. Let's see more examples. So let's see this example. Now this is your disjunction. For this you can check it out. This operation, this is also monoid but not group. This is also monoid because the identity element, you have identity element and that is false. For this disjunction, this is your disjunction operation in the propositional logic. So this is monoid because there is identity element. This is closed also. So the closure property is satisfied. Also this is associative. This disjunction, this is associative. This is not a group. This structure is not a group. Why this structure is not a group? This structure is not a group because there is no inverse of true. For example, remember the false inverse, that is false. There is no problem. False inverse is false, but there is no inverse of true. For example, if I ask you, what should I write here such that I get the identity element? Identity element is false. So what should I write here such that I get the identity element? The point is, this does not exist. This does not exist. If I put false here, then true or false will be true. If I put true here, then true or true will be true. The point is, this true or anything that can never be false. So I can say this true inverse does not exist. So you can see this true inverse, this does not exist. And this is the reason I can say this structure is not a group. But because this is a binary operation, so this structure we can represent using the Cayley table. You can simply represent this using the Cayley table like this: true, false, true, false. Now you can easily see this will be like true or true, that will be true, true or false, that will be true, false or true, that will be true, false or false, that will be false. So your final Cayley table that you will get will be this. This is the Cayley table for this structure. You can also call it multiplication table. You can see this operation is not multiplication, but still this table we call it multiplication table. So you can call it multiplication table, or you can call it Cayley table, or you can call it operation table. So these are the different names for this table, for this representation. And you can see this is like a 2D array representation. Either you can see two-dimensional array, or you can see this is like a matrix representation. Now let's see the next. What about this structure? 0, 1 multiplication. This is the multiplication. Now this is the multiplication operator. This is your multiplication operator. So now you tell me, what is this structure? First of all, you can see this is closed. The closure property is satisfied. Also you can notice this multiplication is associative. So I can say definitely associative property is also there. And what is the identity element? The identity element also we have. So this is a monoid. Because there is identity element, for multiplication this 1 is the identity element. But remember, this structure is not a group. Why this structure is not a group? Because you can see 1 inverse is there. Identity element inverse will always be identity element. This 1 is the identity element. Identity element inverse will always be identity element. But what is the inverse of 0? If I ask you, what should I put here? What should I put here such that I get the identity element? What should I put here such that I should get the identity element? If I put 0, then 0 multiplied by 0 will be 0. If I put 1, then 0 multiplied by 1 will be 0. So you can see that 0 inverse does not exist. For this structure, 0 inverse does not exist. And because 0 inverse does not exist, so we don't have inverse property in this structure. So this structure is not a group. But this binary operation, this multiplication, this structure also can be represented using Cayley table. You can create the Cayley table very easily. 0, 1, 0, 1. So very simple. 0 multiplied by 0, 0. 0 multiplied by 1, 0. 1 multiplied by 0, 0. And 1 multiplied by 1, that is 1. So finally, this is the Cayley table representation for this structure. Let's see one more example. Consider this structure. Is this a group? The answer is yes. Yes, this is a group. Finally, this is a group. Why this is a group? Because you can notice, first of all, multiplication is associative. Multiplication is always associative. This is closed also. Closure property is also satisfied because 1 multiplied by 1 is 1. 1 multiplied by minus 1 is minus 1. Minus 1 multiplied by minus 1 is 1. And you can notice, so whatever two elements you take, same or different, you can see if you multiply them, then the result will be in this set. Then the result will be either 1 or minus 1. So I can say closure property satisfied, multiplication is associative, so associative property satisfied. And you can notice there is identity element also. For multiplication, identity element is 1. So this is monoid also, this structure is monoid. And you can see there is inverse for every element. There is inverse for every element. The identity element inverse will always be identity element. You can see 1 is the identity element. So identity element inverse will always be identity element. And you can also see what is the inverse of minus 1. The inverse of minus 1. What should I write here such that I get the identity element? So what should I write here such that I get identity element? And the answer is I should write minus 1. So minus 1 inverse, that is also minus 1. So you can see 1 inverse is 1, minus 1 inverse is minus 1. So anyway, this structure is a group. Okay, so you can create Cayley table for this structure also very easily. You can create. So this is your multiplication. These are the elements that you have, minus 1, 1. Now you can just simply say minus 1 multiplied by minus 1, that will be 1. Minus 1 multiplied by 1, that will be minus 1. 1 multiplied by minus 1, that will be minus 1. 1 multiplied by 1, that will be 1. So you can see this is the Cayley table for this binary structure. I hope you understood the concept of Cayley table. Cayley table or multiplication table or operation table, all these are different names for the same thing. So any binary operation on a finite set you can represent using a two-dimensional array, or you can say using a matrix type of representation, that is called Cayley table. Okay, so you can see, for example, if this is your set and you have multiplication operation, then this Cayley table you will get, you can check it out. So very simple point, in a Cayley table, remember this entry, what this entry will be, you can see this entry will be row is GI, column is GJ, so this entry will be GI star GJ. Don't say GJ star GI, this will be wrong. Okay, so remember very simple point, that in this Cayley table, this entry will be row is GI and column is GJ, so this entry will be GI star GJ. So this is how. Okay, so if your set is finite set, so any binary operation on a finite set can be represented using a Cayley table. This is the point. Okay, so this type of Cayley table you will get, as I told you, this entry will be X star Y. Okay, because X is the row, Y is the column, always go from row to column. So this entry will be, remember, X star Y. Don't say Y star X. Okay, so simple. So this is the point. Now in this Cayley table, this Cayley table is given to you. In this Cayley table, tell me what is B star E. In this Cayley table, if I ask you what is B star E, so you can see B star E. B star E means this column, this entry is the B star E. So you can easily notice in this, the B star E, that is B, row B, column E. So this entry is B star E. So you can see B star E is equal to D. And similarly, what is E star B? You can see this is the row E and the column is F. E star B. The question is asking E star B means row E, column B. You can see E star B. This entry is E star B. This entry is E star B. So you can see E star B entry is F. Okay, so very easily you can see this is your Cayley table. Now let's move on. So this is the Cayley table for this group. We have already seen this group. This is the roots of unity. This complete analysis of this group we have done. Okay, so this is under multiplication. If you notice, this is the roots of unity. Okay, square roots of unity. So this group, the complete analysis of this group we have seen. This is a group, this is a abelian group, and if you create the Cayley table, you will get this Cayley table. You can check it out. Let's solve this question. Let G be a group. So this G is already given to you as a group. So you don't have to check for associative property. You don't have to check for identity element. You don't have to check for any property, inverse property. You don't have to check. It is already given that G is a group with operation star. This star can be any operation. Okay, this is group operation. This star is simply group operation. This can be any operation, we don't know. And this Cayley table is already given to you. Now the question is asking, find what is B star D. So from this Cayley table, what is B star D? So if you notice, B star D means row B, column D. So this entry is basically the B star D entry. So this entry means I can say B star D is equal to A. So I can say B star D, that is A. What is DB? First of all, let me tell you, when you simply write like this DB, then what it simply means? This, remember, it means D star B. Remember, everything will happen, okay, in a group. If you have this group, in this group, only this operation you can apply. In one group, you have one operation. So remember, for this group, the only operation is this star. So if I write like this directly DB, it simply means that I want to say D star B. Okay, so if I write like this, for example, D dot B, that also means D star B. One group has one operation. So this group has only this operation. So when I write like this DB, it simply means D star B. Now you tell me what is D star B. So you can easily notice D star B means D is the row, B is the column. So this entry is a D star B entry. This is the D star B. So D star B is equal to F. So here you can notice the answer will be F. Now, what is BBABC? First of all, is there any ambiguity here? I am asking that, is there any ambiguity here? So if I ask you, for example, if I ask you what is ABC, so should I ask you this parenthesis or should I ask you this? Means, are they going to be different? Is there any ambiguity here? Can I write like this? The point, this is what I am asking. If I ask you ABC, first of all, when I ask you ABC, it simply means I am asking A star B star C. First of all, this is the point. I am asking A star B star C. But in this you tell me, what should I do? Should I do this or should I do this? What should I do? The answer is you can do both of them because they will be same, because we are talking about a group. because this is already given to you that this is a group. So this group is associative. It simply means this star operation, this star that is given to you, this star operation is simply associative. And because this operation is associative, so you can remove the parenthesis. There is no need to put the parenthesis. For example, here you can notice we do not have any brackets, we do not have any parenthesis. And the reason is because we are talking about a group is associative, so this operation is associative. And because this operation is associative, so this expression will be same as this expression. So this is completely unambiguous. I can say this is completely fine. If I remove the bracket, that is completely fine. I can say this expression is fine because we are talking about a group and group is associative. So it simply means this operation is associative. So I can say because this operation is associative. Because this operation is associative. So this is the reason. So if I don't give you parenthesis, that is also fine because your operation is associative. So you can see these two things will be same. If you evaluate like this, the answer will be same as if you evaluate like this. Both will give you the same answer. Let's check it out. For example, let's calculate ABC. Let's calculate in this question. Let's find out first. Let's start with ABC. Remember, ABC means A star, B star, C. Now I am telling you that if you calculate like this, if you calculate A star B first and then you calculate C, then what your answer will be? So you can notice what is A star B. A star B means this is A, this is B. A star B means D. So first of all, A star B, that means D. So this will be finally I can say D star C. What is D star C? This is D, this is C. D star C is A. So I can say that the final answer will be A. Now similarly, remember, if you want, you can evaluate like this also. This is also fine. For example, if I ask you what is A star B star C. So first of all, what is B star C? First of all, what is that? You can see B is this. So row is B, column is C. So B star C, that is E. So I can simply say that B star C, that is E. Now finally, what is A star E? You can see this is the A, this is the row A, and this is the column E. So you can see A star E, that is A. So here also you will get A. So you can see if you do like this, then also answer is A. And if you do like this, then also the answer is A. So this is why I am saying that this expression is unambiguous. This expression will be finally A. Now you tell me the answer for these expressions. For example, what is the answer for BBABC? BBABC. This is completely unambiguous expression. And remember, this means, first of all, what this means? This means B star, B star, A star, B star, C. Because the operation is star. In this group, only one operation is there. This operation we will apply. Okay, so basically between these two there is a star operation. Between these two there is a star operation. Now you can calculate this. You can easily calculate this because this is a group. So star is associative. So you can calculate like this very easily, one by one. You can go. Okay, so you can calculate. For example, what is B star B? This B star B. This is B. This is B. So B star B is going to be C. So I can simply say that this will be C. Now you tell me what is C star and so on. So you tell me now what is C star A? This is C, this is A. So C star A is D. Because row is C, column is A. So this C star A, this entry, I can simply say that this entry is simply C star A. This entry is C star A. So C star A is D. Now you tell me D star B star, D star B. What is that? This D star B, what that will be? So this D star B, this is D, this is B. So this entry is a D star B. So I can say D star B is F. F star C. Now finally you tell me what is F star C. So you can see that this is F and this is C. So this entry is going to be F star C. Remember this entry, that is your F star C. So your final answer will be A. So I can say this BBABC, the answer will be A. What is BBBB? What is that? BBBB. So you can see BBBB. What is this? What is this? Very simple. First of all, what is BB? This is B, this is B. So I can say B star B. Remember, this is your B star B entry. This entry is simply B star B, or I can say this entry is simply BB. This entry is basically BB, or I can say B star B. So I can say B star B, that is C. Now you tell me what is CB. What is CB? CB, that will be, this is C, this is B. Row C, column B. So the value will be E. Now finally you tell me what is EB. Means the row E and column B. So this entry, you can see this entry is E star B. This entry, remember this entry is your E star B, or you can simply call it EB. So final answer will be B. I can say here the final answer will be B. Similarly, you can calculate what is E star, what is this, what is E. You can simply see what that will be. So you can notice, first of all, what is EE? EE. So E, this row is E and column is E. So this entry is EE, means E is E. You can also see, so this E will also be E and this E also will be EE. So finally I can say your answer will be EE. Okay. So very easily you can do this. So I hope you understood the concept of Cayley table, how to use the Cayley table. Okay. So these questions, I hope these are telling you everything about the Cayley table. One thing I want to tell you, that if you have any structure, for example, if I give you this type of structure, like if you have this, or maybe if I say that, for example, if you have a group G comma hash, if I give you this group, in this group, if I write AB, then what that means? So first of all, in this group, if I write this AB, then what that means? That means A hash B. Okay. Similarly, in this group, if I write A, B, C, then remember, this is completely unambiguous. This is completely fine because it is a group. So I can say this operation is associative. So, okay, this is fine because this operation is associative. So you don't need parenthesis. I don't need to give you parenthesis. Okay, the point is this is completely fine. Of course, if you want to calculate this, you can either calculate like this or you can calculate like this. That is your choice. Okay, that is your choice. You can calculate like this or this. Okay, so these are the concepts. I hope you understood the concept of Cayley table.